Hello students, today we are conducting experiment using Reynolds apparatus. So as you know, Reynolds number is ratio of inertia force to viscous force, and that is given by Reynolds number is dV upon nu, where nu is kinematic viscosity of fluid, d is diameter of fluid through which the diameter of tube through which fluid is flowing, and v is velocity of fluid. So in the experiment, we know the pipe diameter, so we can calculate this pipe diameter using equation pi by 4 d square. Then flow, we can calculate flow in meter cube per second. We can calculate flow, we can measure this flow using a measuring tank and stopwatch. We can measure this flow. So if we divide this flow, which is in meter cube per second, by area of pipe or duct through which the fluid is flowing, we get velocity in meters per second. This Reynolds number is d is diameter of duct, v is velocity, and nu is kinematic viscosity. So these are constants, so these values are known. Kinematic viscosity of water 1.01 into 10 raised to minus 6 meters per second, and diameter of tube is 0.014 meter. Now we have already studied the flow regimes, laminar, turbulent, and in between laminar and turbulent is transition zone. We are now allowing water to flow through a tube, transparent tube, and we are controlling the flow. That is why we are controlling the velocity also. That means we get different Reynolds numbers, and depending upon that we are checking whether the flow is laminar, turbulent or transitional, depending upon the flow conditions. For a pipe flow, the flow is laminar till Reynolds number is 2100, and the flow is turbulent when Reynolds number is greater than 4000. In between that, that is for Reynolds number 2000 to 400, it is transitional, and we are verifying this. So we are taking some 6 readings, possibly 2 for laminar, 2 for transitional, and 2 for turbulent. This is experimental setup. This is on off switch. We can start and stop this pump. This is sump tank, and this is drain cock for the sump. This is bypass valve. So the liquid is sucked in the pump through this pump, and then it is pressurized and transported. This is bypass valve. So some fluid goes to the overhead tank through this pipe, and remaining is bypass, that is returns to the sump tank. So this is overhead tank, and this is a small tank used for storing a dye. A dye is injected in the water flow, and by observing the dye, we can conclude whether the flow is laminar, transitional or turbulent. So from this overhead tank, this is bell mouth entry, and the fluid flows through this transparent tube, and then again it returns to the sump tank. So this is recirculating type, and we can control flow of water using this valve. Then for measurement of flow rate, for flow measurement, now in this case the arrangement is slightly different. This is the pipe, and this pipe is connected to transfer water from this pipe to measuring flask. So using this pipe we are transferring fluid, collecting fluid in this measuring flask, and we are collecting this some measure quantity of liquid, and time taken for that is noted. By knowing that, we can calculate velocity of fluid. Now you can see that the flow is laminar. We can see clearly the flow. So laminar flow means the flow is taking place just like one sheet sliding on one lamina or sheet sliding on the other. So this is laminar flow. So we are finding Reynolds number for this, and we are collecting this for this flow of fluid for 10 seconds. So this is 100 ml for 10 seconds. Similarly, the experiment is carried out for varying flow. So this is laminar. Now the flow is becoming unsteady. So this is transitional. So this is transitional region. And then for very high flow rates, it is turbulent. We can't see a dye. So this is turbulent. So again, if we control this flow and if we reduce velocity, the flow returns to laminar case. Now you can see the dye clearly. So this is laminar case. So we are collecting readings and I am giving you the readings, different readings. This is the experimental procedure. So we have taken these readings, we have kept time duration constant for all readings 10 seconds. That is, we have collected water in 10 seconds for the different wall positions. So the different quantities collected are 140 ml, 170 ml, 275 ml, 290 ml, 490 ml and 590 ml for 10 seconds time. So using this data now you calculate this Reynolds number, and by the condition it is, if it is less than 2100 it is laminar flow, and if it is greater than 4000 it is turbulent flow, and in between it is transitional flow. You write your comment for the flow description.